Welcome to Weld School. This video is all about tungsten. If you like this video, give it a thumbs up and feel free to subscribe. Here is the chemical symbol, which is found on the periodic table of elements for tungsten. It's a W because the name actually comes from Wolfram, which is a German word, and where we get tungsten from is from ores of wolframite and scheelite. So that's where the W comes from. Some characteristics: tungsten itself is a silvery whitish metal. It is dense, hard, and brittle. Okay, pure tungsten is actually softer and more malleable than anything that's less than pure. So the more pure you get, the more it'll actually have some flexibility to it, or it'll be a little bit softer. With that really being said, its tensile strength is 500,000 pounds. So basically, if we take this rod and we try to pull it apart, pulling that way and this way, it is 500,000 pounds minimum tensile strength. While we look at something like this is our ER70S2. We commonly use for steel TIG, or it's the same rod used in MIG, except usually we use a 6. But anyways, we try to pull this apart. The minimum yield on this is 70,000 pounds. And your base metal, let's say this is A36, a minimum yield of 36,000 pounds. So put that into perspective: 500,000 pounds, 36,000 pounds. Okay, we are not using tungsten as a filler metal. It is the electrode for many reasons. First one, it's got a melting temperature of over 6,000 degrees Fahrenheit. I believe it's exactly pure tungsten is 6,192 degrees, and that is by far the highest melting temperature of any element on the periodic table. The tensile strength is the highest of anything on the periodic table as well. It's got a high heat and electrical conductivity. So what that really means is this gets hot here, it's going to travel through this electrode quickly. So we're able to release that heat quickly. But also when we're grinding, say we're here grinding this on a wheel, if we're holding it with our bare hands, your hands are going to get hot pretty quick because that heat's going to travel down to your fingers. Okay? Electrical conductivity is extremely high, meaning that electrons will freely flow through this electrode. Okay, it's not as high as like silver or gold or even copper, but it is a very efficient electrical conductor. With that being said, there's a couple other things about it. It's very corrosion resistant, so you expose it to water, air, even a lot of chemicals. Really nothing happens to it. Go ahead and throw this outside, let it rain on it. Nothing's going to happen. Okay, it's got one of the lowest coefficients of thermal expansion of any pure metal, and really all that means is as this thing gets hot, is it expanding and contracting as it heats and cools? And no, it pretty much will stay close to its original size. So there's a lot of benefits to using tungsten, and we basically use it in gas tungsten arc welding or TIG, and it can also be used in plasma arc welding. So the next thing we're going to cover is the tungsten electrode sizes. So you'll see that we got a list here, and we're going to be able to find tungsten available from 0.010 of an inch all the way up to a 1/4 inch. Okay, if you find a 0.010, it's up to 15 amps. That's it. So we're talking about basically welding gum wrappers together. Okay, pretty thin stuff. 20,000 is 5 to 20 amps. So hey, you have an example of that. That's a 20,000 electrode, which is hard to hang on to because it actually has got a little bit of a bend to it. Always afraid I'm going to snap it. You need to have a collet body that actually fits and a collet for a 20,000, which is very tiny. Okay, so here we go, 20,000 of an inch. That'll run, again, 5 to 20, 40,000 of an inch. Okay, so very similar to the thickness of your 035 MIG wire if you want to use that as a comparison, very close to that. 1/16 of an inch is something where you actually start to get into sizes you might more commonly see. 1/16 is still kind of small. We burn just lots and lots of 332 in our welding program. 332 gives us 150 to 200 amps, plenty for even our AC welding that we might hit up to 200, maybe even more in some cases. 1/8 of an inch is another really common size. Although when you look at what its range is, it might be a little overkill at times, but really the idea is maybe at a little overkill if you're TIG welding on pipe, maybe just to prolong the life of that tip, okay? We have 532, 3/16, and 1/4 inch. I don't have 532, 3/16, but I do have this monster right here. This is almost like a novelty. This is a 1/4 inch thoriated tungsten. And this thing will actually run from 750 to 1,000 amps. So we go from something like this to this. So 20 thousandths, 1/4 inch. I don't even have the 10 thousandths again, but just a huge range. Anything can be welded. The thickest, the thinnest you can imagine, it's out there. They make a size for it. Let's continue on. Which tungsten should I buy, or what should I actually use? So there's a whole list of different types of tungstens. They come in different flavors, as you can see, with the paint band on each of these with different colors. But let's start here. Let's look at what the actual electrode classification number actually means. So we have E, always electrode, W is our tungsten, and then we have our X or question mark, either way, and then we have the same here. What are we actually looking for on the percentage? Okay, so we have what we call the pure tungsten. Okay, so that is 99.9% pure tungsten, and that's the green one. And it's not something that people typically choose anymore. It's not as good. It's not going to last as long as these other tungsten options that we have out there. And really what the difference is that the rest of these are actually combined with an oxide. Okay, and so that oxide could be thorium, lanthanum, cerium, zirconium. This is that triple blend, which is the lanthanum, yttrium, and zirconium blend. Okay, so if we see an EWP, that is pure, you won't see anything past it. If you see EWG, it's just a general classification for tungsten, okay? But now we're starting to look into EW, maybe TH, okay? And that's thorium oxide. And so we can find these in a 1 or 2% typically. They actually do make a 4% thoriated tungsten out there. One thing you want to keep in mind with your thorium is the fact that it is radioactive. Okay, so some of the manufacturers have actually stopped making these because of the mild radioactive material as you're grinding it can get up into the air. Okay, but a lot of the old timers say 2% thoriated is the ultimate. Okay, lanthanum comes in a couple different types. You'll have a blue, a black, or a gold, and it'll be 1%, 2%, and 1.5%. I am a huge fan of the 2%, the blue, the 2% lanthanated. It's a phenomenal rod. I've had a lot of really good luck with that rod personally. Like when we talk about longevity, you grind it, you weld, you don't contaminate, and the thing just lasts and lasts. Okay, seriated is what we use here at our school quite often. It's just a general purpose rod. We use the 2%. Zirconiated is a great AC rod, and that's the brown one. I didn't have a brown marker. That's the closest I could get. And then this LAYZR, the laser rod, which can come in purple or it's like a green. They call it chartreuse. That's kind of where everything's been going to. A lot of these tri-blends. See if I have one here. So you can see it's got that like greenish band It's called chartreuse. I think I have some purple, but I'm not going to pull it out here. I am going to put together a video on how to grind it properly. I was going to add it to this one, but it's actually getting a little too long, so check that video out next. So this is a little bit about tungsten. We talked about its characteristics. We talked about the sizes it comes in, and now we're talking about the different types you can find.